Yeah, good morning, everybody, and welcome back from your JAM examination. I wish all of you all the best and excellent results in Jesus' name. Alright, so welcome to physics practical class. My name is still my name, Mr. Lawa, your physics teacher. So, since we are all know that we are preparing for waec 2025, that has already started, so we have been given specimens to examine, and likewise where your question will come out for the physics practical. You all know that when you talk about physics practical, you have 3 questions that will come out and you must answer 2. When I say 3 questions, the first set of questions is always mechanics, number 2 is always geometric optics that you call lights, and number 3 is electricity. From my observation for the past 2 decades I've been in this profession, what I always observe as students or candidates, they always run away from question 2. They always run away of question 2 that we call geometric optics. Why? I will tell you the reason why students run away from geometric optics. Number 1 is because of this thing, glassy material. How will I handle this thing? How will this thing not fall from me? The fear of holding glassy material, that's number 1. Number 2, how to read the light ray through the glass. It's also a fear to students. I guess students also fear that. Like, how will I see? And I don't blame the environmental factor, because if the light is not bright enough, you will not enjoy it, because the topic itself is called lights. That is, you need light. Number 3, how to draw. And a lot of things, how to draw the factors of the light I've said and the lights. But I'm very glad to tell you that if you are very sound in theory, that all your calculations, your formula, you know them and you know how to use them very well, you won't have any issue with anything called practical. So that time I'll be telling you guys that someone like me, I can do practicals on a spot without carrying out experiment. Since I have my formulas in my brain, I'll put the formula down and I'll get a perfect result that you are doing experiment will never get. I guess my language. When I say we never get that result, because the environmental factor is for you that will affect your results. Now, this morning that we are doing preparation for waec 2025, so I want us to pick number 2. This one, one of the question that will come out, we'll talk about refraction. So that's why I'm bringing out a question, a related question. That's why I'm making a reference. Wassce 1989. I will not write the question on the board. You have the past question with you. Wassce 1989. The Wassce 1989 that we can all see in our various past questions. That's what we will be reading, and from there we will also bring out what is needed. Now, before I go on, this is a glass. We all know the refractive. Listen now. When you talk about refraction, what we want to bring out majorly is refractive index. All of that is they are under the concept of refractive index. Now, look at this glass now. We all know when you talk about refractive index of glass, several times you have been told in the theory class, refractive index of glass is always 1.5. At times, if it will vary, it will be in the range of maybe 1.5, 1.1, 1.51, 1.52, 1.55. It's like 1.55. I guess my language, I'm talking about the measurement. So you are now the one that will decide. Let's say I am picking 1.5 as my refractive index of the glass. I guess my language now. No matter any value given to me, I'll be working with it under the principle of second law of refraction. If you remember the second law of refraction that you call Snell's law, we state that the ratio of the sine of an angle of incidence to the sine of an angle or of an angle of refraction is constant. What am I saying is that sine I over sine R equals to constant. This constant, we call it Snell's constant, because this law was stated by a scientist called Snell's law. Snell's. The law was called Snell's law. Now, since I have no refractive index, they will give you in the question angle of incidence. With this formula, just make my sine R sort of formula, and at the end of the day, I will do inverse of sine. Now, without wasting our time, normally we have your paper, you want to draw, we are still coming there to come and draw and do the tracing. I have my rectangular prism. I have my pen, where 2 pins will be used for objects, 2 pins also will be used for image to trace. That one represents my P1, P2, P3, P4, that is the image. And likewise, if I'm on board, on drawing board, I will need a pin that you call maybe staple pin to staple all these things so that the thing will not move. But because of our time, I will be reading the question and I will be interpreting. They said we should trace Yes, I will need somebody to come over and do the tracing for us. Yes, someone should come here. You will be doing the tracing for us. Alright, maybe that penny that time the person will come. Let me just read out. They said we should trace. Pencil. You have a pencil there. Alright, no problem. Let's just continue. You'll be doing that one later. So just continue with your own. So they said we should trace E, F, G, H. E, F, G, H. E, F, G, H. That means there is no way you will trace. And that's one of the reasons why students running from this practical is how to draw. Because if these experiments will be repeated 5 times, you will draw this thing 5 times. And because of the accuracy, so we run it from like, how would that be perfect on this thing? Let me run it from it. Let me go for mechanics that has just readings to submit and electricity readings to submit. You will not ask of any maybe practical work that I might have done in my hidden place. Now, they said, given the rectangular block which I have done, remove the glass block and draw a normal KL. My normal means the perpendicular line. Normal, just perpendicular line, 90. KL. KL, I think this is the KL that you are referring to. The way it has been labeled here, KL. This is the normal perpendicular line, KL. They now say something. Cutting the faces at at X. Cutting the faces at X. That is S. That is like our you that you are doing mathematics. You know, we have something called maybe like a midpoint. That is a point that the thing is forming the perpendicular. That is X. Now, and Q. S and Q. Good. Such that ES is about 1/4, that is 1/4 of the whole diagram. 1/4. ES is about 1/4, and E and what? And EF and of EF full stop. The next is something. Draw a line making an angle of incidence I equals to 30. This I you are seeing here is 30. Like I've told you, whenever you are doing practical, when you are reading through the lines, what makes science to be very sweet is that we have manual, we have principle that guide all of us. As you are reading, you will be following it. That is, in this statement, I need something. I need angle of incidence. I can start preparing my table. Maybe I should be somewhere around here to prepare my table. That is, I will have my I. That is, I need I. My first I mentioned there is 30. I will need I values. This is my table of values. Table of values. And one more thing you need to know, since you are writing waec, let me give you all the way where the mark student write and where the mark them wrong. On your graph, everything must be pencil. And what are those things you can do on your graph? You plot your graph, you write your scale and title on your graph with pencil. While all the write-ups will be on your scripts. Am I communicating that? Like your table of values will be written on your book, on the booklet, not on the graph. Am I communicating right now? So, please, exam is coming, so we need to be guiding ourselves on way out. There is way between you are brilliant, that you know what you are doing, and the way to handle things. Some may know the whole concept, but how to present yourself. If you present yourself wrong, then it will be assumed that you are what? You are poor. I get my hand now. Your output matters as well. As you are increasing your input, let your output also show that you are working. Am I communicating right now? Because of our time, they said, draw a line making an angle incidence I 30 degrees, which I have done here. Now, they said something. With KS as shown, draw 4 other lines for I equals to 35, 45, 55, and 65. You write, I'm bringing my table of values like this. I need 35. I don't need to put angle here again because angle is already here. Whenever unit is here, you don't repeat your unit again. 30, 35. What again? They said 30, 35, okay, 45. 55 and 65. Are you there now? Alright, we are still coming to our way of using theory to set this thing, but let's first read what they want us to do before we now come with our own mindset of using theory and turn theory to practical. I guess we're learning now. Alright, now leave it outside. It says something. Replace the glass block carefully on the south line. Fix 2 pins. They are only reading their result, pin 1, pin 2, and at P1 and P2 on the Z line. Make an angle of incidence 30 with KS. I'm fasting right now. By looking through the side HG, the other side, side AG, that's the one of the issue. Just be looking. I can't see. I will do this, I will do that. That is where we find ourselves. But when you are smart, there is a difference between hard work and smart work. what can give you results is your smart work. Talking about hard work, you have been doing hard work starting from your year 10, SS1, SS2, SS3. Now you need results, so you need to be very smart so that you can all your journey will not be a waste. Am I communicating right now? All right, moving forward. Leaving that side again, they said fix two other pins P3, P4, such that the pins at P3, P4 appear to be in line. Now I've told you whenever you are doing that, you want to see something that will look like a straight line. How can I make 4 people to be one? So that you not scatter. That's something. I want to make 4 pins to be what? To be one. That's my target. By looking to the other side. So such that the pins, all those things. Now remove the glass block, draw a line to pass through all this now. I want to be very fast to bear with it. They said measure and record ST1. Measure and record ST1. This is my T1. That is, I need the distance from here to here. Since they said measure, it must be part of your parameters. It must be part of your parameters. S what? ST1, alright? ST1. Now, since my ST1, no, you use ruler to measure that one. So that one, the unit will be centimeter. The unit will be centimeter. The unit will be centimeter. We are still coming to our paper. Alright, that is ST1. I continue. I'm on measure. Measure and record ST1 and XI, that is X1, T1. X1, T1. That is, we need, this place is our X. We still measure this place now. It's like they want to bring out something you can call about your taking of your real depth, apparent depth, and what you call the apparent or displacement. Apparent displacement, the distance between the real depth. That's why they are marrying these things together. That what you are saying and where it's supposed to be. I get my line that this I need a particular table also for X1, T1 because I measure the ruler with ruler to be in centimeter. Am I with you now? Alright, I continue. Because of time, they said something again. They now said plot the graph. They said repeat the experiment for I equals to 35, whatever. Now they said plot a graph of ST on the vertical axis. This will be on the vertical axis when I'm plotting my graph. That is, when I'm plotting my graph, ST will be here, and they said something, and on vertical, and ST will be on the horizontal. That's how the graph will be. You know your title as usual and your scale as usual. Are you with me now? When we get to graph aspect, we'll be talking about that. The reason why we are here number 1 is to talk about how we can do this thing in a smart way. Now, how can we do this thing in a smart way? That's where we are going to now. That's where we are going to. That I don't want to stress myself with these materials. Why must everything just be like we follow every procedure, every like that? No. I have told you this is a glass. Refractive index of glass. We have the range from 1.5 to 1. It depends on the material, but majorly 1.5 to 1.55. I get my line now. Let's see my. And look, one more thing. Before you start anything on this your paper, the first thing you must do is that you write the thickness of your what? The thickness of your what? Of this prism, rectangular prism. When you will write it there, I get my line now. Are you getting me now? That's the first word because that's what they use to mark you. Is it clear to you now? Alright, leave that side now. I want to use my formula without it now. I have agreed that my refractive index. Hello, you will not write this one on your. You find your rough sheet. You do that one. That your rough sheet is not your own practical and your own. That is your own cooking. That's your own kitchen where you are cooking things that nobody will see. You won't allow someone to come to your kitchen, but you can allow someone to eat your food. Are we there now? So we have my refractive. This is my kitchen now. That is my rough sheet, 1.5. Where my eye, they say my first eye is 30, right? My first eye is 30. Look at it now. My first eye is 30. From there, no, they didn't have to be refraction. They didn't have to be refraction. I must not put refraction here. But that's the reason why I want to achieve refraction. Because any angle I achieve here will be strengthening this thing. It will be increasing the length of this thing or reducing it. Am I complicated right now? So that's why I want to go and prepare that. It's one that will give me edge of this line. Clear? Alright, now look up. I have my my eye, angle of distance. Now I want to find my R. With my formula of Snell's law, this formula, I will say 1.5 equals, yes, sine high, please join me in working it out. Join me. so that we're very fast. What will be 1.5 equals to sine 30 over sine f r. Now I need your response, make it fast. So sine r equals to sine 30. Can you feel it very well? Over 1.5. So what's my sine 30 mathematician? 0.5 over 1.5. So I have sine r equals what? That is what? Calculator? That's 0.333 and so on. Fourth got it right? Check your fourth got it. You know this is 1 over 3. 1 over 3, 5 over 15, 1 over 3, 0.33, like that. So alright, r will now be the inverse, the sine inverse of 0.333. So when you come up with the answer, you will have something like what? You can check for me to verify what I'm doing. What's the inverse? That should be 90 point what? Give me something.
That's
19.47. Approximately, I can say my R is 19.5. Now, go. I don't have my compass here. Anybody with compass here?